Hello friends, welcome to Learn Chemistry with Shubham, where you will get all chemistry related knowledge and tricks. So, like, share, and subscribe my YouTube channel. Thanks. So today we are going to discuss how to predict RS configuration. So basically, when a carbon is attached to four different functional groups, then that carbon is known as chiral carbon, and chiral carbon shows optical activity, and this chiral carbon can be assigned RS configuration. So today we are going to discuss how to assign RS configuration to a chiral carbon. So before going to assign RS configuration, we have to remember some points and in the order, same order. So first point is the first priority goes to that atom with highest atomic number. So basically, when you are assigning priorities to functional group, the priority depends on the atomic number of the atom directly attached to the carbon atom. Okay, so first priority to the atom with highest atomic number. Second, if two or more groups have same atomic number, then go to the next element. Third, if isomers are present, then priority decided by atomic mass, that is highest atomic mass atom will get first priority. And fourth rule, if triple or double bonds are present, then consider the atom that many times. For example, if a triple bond is attached between two atoms, then consider that atom triple times, or double bond if present, then two times. Second, rotating the groups. First, when you assign the priorities, then you have to rotate the groups. How to rotate? Go from first priority group to second priority group, and then second priority group to third priority group. You have to go from first priority group to second, and then second priority group to third priority group. And you have to remember one thing: neglect fourth priority group. Okay, you don't have to consider fourth priority group, you only have to consider first priority group, second priority group, and third priority group. When this rotation is in clockwise direction, then your configuration will be R configuration, and if this rotation is in anti-clockwise direction, this configuration will be S configuration. Okay, in short, म्हणजे सांगायचं झालं तर काय करायचंय, तर सगळ्यात अगोदर तुम्हाला तुमच्या कार्बनला चार वेगळे फंक्शनल ग्रुप अटॅच असणार आहेत, आणि जे डायरेक्टली ग्रुप्स अटॅच किंवा ॲटम्स अटॅच असणार त्यांची तुम्हाला प्रायोरिटी ठरवायची. तर ही प्रायोरिटी ठरवताना तुम्हाला सर्वात अगोदर लक्षात काय ठेवायचंय, ज्याचा ॲटॉमिक नंबर सर्वात जास्त असेल त्याला पहिली प्रायोरिटी. ज्याचा ॲटॉमिक नंबर जास्त असेल किंवा दोन पेक्षा जास्त ठिकाणी ॲटॉमिक नंबर जर सेम येत असेल, तर तुम्हाला नेक्स्ट एलिमेंटकडे जायचंय. तिसरा पॉईंट काय सांगतोय, जर आयसोमर्स प्रेझेंट असतील तर तुम्हाला ॲटॉमिक मास नुसार प्रायोरिटी ठरवायची, म्हणजेच ज्याचं ॲटॉमिक मास सर्वात जास्त असेल त्याची प्रायोरिटी सर्वात जास्त असणार आहे. आणि जेव्हा ट्रिपल किंवा डबल बॉन्ड असतील त्यावेळेस तुम्हाला काय करायचंय, त्यांना त्या संख्येमध्ये मोजायचंय. तसं या सर्वांसाठी मी एक ट्रिक बनवली. द ट्रिक इज दॅट ऑलवेज रिमेंबर अल्फाबेट्स इन इंग्लिश विथ MNO PQRS are neglected, and then T, MNOT or D, where N is the atomic number of the atom, N is the M is the atomic mass of the atom, O is the other element or next element, T for triple bond, and D for double bond. So priority always given on the basis of atomic number. If the atomic number is same, then you have to go to the next or other element, therefore O. And if there is presence of isomers, then you have to assign priority on the basis of atomic mass. If atomic number is same and then triple or double bond comes in the story, then the triple bond will be more prior over double bond. Okay, so let's start with the examples. Here you can see that there are four types of examples. In first example, it is Fisher projection formula, in which here the central carbon atom is your chiral carbon, because four different functional groups are attached to it. So priority depends on the atomic number, because in these four functional groups I can see that there is no atom with same atomic number. So the priority will be purely based on the atomic number. So first priority will goes to bromine because it has highest atomic number. Second will go to oxygen. Third one goes to carbon, and fourth will go to hydrogen. Always remember, hydrogen will always get least priority because its atomic number is least. So after assigning the priorities first, second, third, fourth in Fisher projection formula, you always have to remember that the fourth priority group and first priority group should be opposite to each other on the same line. same line. So you have to interchange the groups. So in order to get opposite both fourth and first priority group on the opposite side on the same line. So here first and second groups will be interchange. After interchanging you will get, I will only show the priorities. Here fourth priority as it is. Here will second priority group come. Here first priority group will go. Third priority group remains as it is. Now always remember that in Fisher projection formula you always have to do two changes. But in this case you see that the after first interchange, first priority group and the fourth priority group are on the opposite side on the same line. So in this case you have only one interchange. So in such a case when you go from first priority group to second priority group and then second to third priority group, it is anti-clockwise rotation. This rotation is anti-clockwise. This rotation is anti-clockwise. So the configuration will be yes. But always remember here in this case after first interchange, first priority group and fourth priority group are coming on the opposite side on same line after first interchange. Then this configuration will be R because you always have to do two interchange in this case. But in the first example only after first interchange you are getting these groups on the opposite side on same line. So your configuration is yes, but it will turn into R configuration. Okay. So this is about Fisher projection formula. Now second example is about the Wadge dash formula. Second example is about the Wadge dash formula. In Wadge dash formula, the dash line or dot dot line shows the groups which are below the plane of paper and Wadge line shows the groups which are above the plane of paper. So in this case, you have to always first remember assign priority on the basis of atomic number. So in this example, chlorine will get first priority because its atomic number is higher. Then nitrogen will get second priority. Then sulfur will get third priority, and here is carbon atom present which will get fourth priority. After assigning the priority in Wadge dash formula you have to directly rotate your priority groups on the basis of first to second, second to third. In this case first to second and second to third, this is clockwise, that is clockwise rotation. So the configuration will be R. This configuration will be R. Now remember in Wadge dash case when the fourth priority group is above the plane of paper and other priority groups are on the or first priority group on the below the plane of paper, then interchange the configuration. In this case fourth priority group lies in the plane of paper, so here we don't need to interchange any configuration. Okay, so now let's see in the third example. Here you can see that this CH3 group is below the plane of paper which is shown by dash dash dash. Okay, and this hydrogen is above the plane of paper. So you have to assign priority. So basically hydrogen will always get least priority, so it will get fourth priority. Now here is carbon, here is also carbon, and here is also carbon. So same atomic number is presented three sides. So you have to decide priority on the basis of next element. Now at this carbon you can see that there is a double bond, so you have to consider carbon two times. If you are going to consider carbon two times, then first priority will go to this carbon. Now come here at second and third, here is three hydrogen and here are only two hydrogens. Always remember priority goes to that atom which has less number of hydrogens. So here are only two hydrogens, therefore second priority goes to this carbon and third priority will goes to CH3 group. Okay, now priorities are assigned. Now you have to go from first priority group to second and then second priority group to third. This is anti-clockwise rotation. This rotation is anti-clockwise, so the configuration will be yes. This configuration will be yes, but always remember here fourth priority group is above the plane of paper, means near the observer. Always remember one thing, the least priority group should be away from the observer. So this S configuration will change into R configuration. This S configuration will change into R configuration. Okay. Here you have to always remember that the least priority group should be always away from the observer. If it is near to the observer, then change the configuration into R into S or S into R. Now let's come to the fourth example. It is alene system. In alene system, when the double bonds or number of rings are even, then the compound is optically active. Here you can see that the double bonds are 2, that is even number. For these compounds, to assign RS configuration, you have to always imagine a or imaginary axis along to double bond. Then you have to give priorities to the groups attached to that carbon. So priorities will be given to that carbon firstly, on which stereochemistry is not mentioned. Here you can see that suppose this is carbon 1 and this carbon is carbon 3. I am considering it 1 and 3. So on carbon number 3 you can see that here stereochemistry is mentioned. pH group is above the plane of paper and CH3 group is below the plane of paper. And at carbon 1 this both lies in the plane of paper. So first priority will always go to atoms which are in the plane of paper. So first priority goes to pH, second goes to CH3. Now you have to give priority to atoms attached to carbon number 3. The third priority will goes to pH and fourth will goes to CH3. Now this rotation is anti-clockwise. So therefore the configuration is this rotation is anti-clockwise. Therefore this configuration is S configuration. Now always remember, if this fourth priority group is above the plane of paper, then this configuration also should be changed into R configuration. Okay. So it is all about the assigning RS configuration to chiral compounds. I hope this video will be most helpful for your exams. If you like it, share, subscribe and comment on it. Thanks.